Hello, calculus friends. So this lesson that I'm about to start is on absolute extrema of multivariable functions. And it's going to take a couple videos because these are not short. So full disclosure. What I want you to remember is from calculus before, when we were in two-dimensional calculus, if I wanted to find an absolute extrema, that wasn't supposed to jump over there. If I wanted to find an absolute extrema, I could have a graph that looks something like this. And my absolute maximum value is the y value up there, and the absolute minimum value is the y value down there. These are also relative extrema, right? So this would be a relative max and an absolute max, and this would be a relative min and an absolute min. However, if I continued this graph down to here, now this relative min is just a relative min, and my absolute min is that y value. And one of the things I said a lot last year was that absolute extrema can occur at critical points and end points, where critical points are where your derivative either equals 0 or doesn't exist. We're going to do the same thing here, but now we're going to do it for a multivariable function, where I want to kind of look at my surface. Let's see if I can draw this. Probably not well, but we'll find out. Maybe something like that. And this is like inside. Yeah, I'm not doing a good job drawing this, but imagine this is like, I don't know, a Pringle, okay? And if I look at this Pringle, this is kind of like the back side of the Pringle, and this is the front side of the Pringle, something like that, okay? If I wanted to know where my absolute minimum value is, it'd be whatever those z values are. This would be a relative maximum. This would be an absolute maximum. Okay, so again, if you think of a Pringle, like your relative extrema could occur on the ends. If I don't think of that as a Pringle, and instead you think of it as, I don't know, like a hemisphere, my absolute maximum happens inside of it, not on the edge. So what you need to understand is when we're talking about multivariable functions, my critical points are where the derivatives are going to equal 0, and our end points are things along the edge. All right, so we are going to figure that out based on the graphs that I give you. So to find absolute extrema, I'm actually going to read through the steps. I don't always do this, but these steps, there's a lot of them, so I think it's important to follow. Step 1, you always want to draw your region, okay? This region is basically a section of a multivariable function. I'm not looking at the whole thing. I'm looking at a specific cutout, like as though I took like an umbrella and sliced through it with a cookie cutter. All right. Identify any corners of R as some test points. Find equations for the boundaries of R. Find when the first partials, f sub x and f sub y, for the original multivariable function equals 0. Throw those in as test points. Use the boundaries to get single variable functions, take those derivatives, set them equal to 0, get more test points, and then go from there. There's a lot going on here. All right, so let me show you what that ends up looking like. It says find the absolute maximum and minimum value for f of x, y equals that thing on the triangular region bound by the x and y axes and the line y equals 3 minus x. All right, so the first thing I'm going to do is I'm going to draw my region. Here's the y-axis, here's the x-axis, and here's the line y equals 3 minus x. All right, this thing right here is my region R. Now, I'm going to have a surface that I'm basically like projecting this triangle on, almost like a bat symbol, and I want to know which part of the bat symbol is highest and lowest in the sky. I know that's terrible, but that's kind of what we're doing here. So, step 1, draw the region. Check. Step 2, identify any corners of R as test points. All right, so I am going to put some test points over here. And this is going to be xy, and this is going to be f of xy, because if you remember last year when we did absolute extrema, we just identified all the candidates. It's called the candidates test. Identify all the candidates, and then find the highest y value and the lowest y value. We're doing that again, except our candidates are a pair of coordinates xy, and then the corresponding z value from the function. All right. Identify the corners. Okay, so my corners are 0, 0, 0, 3, and 3, 0. Fine, done. Find equations for the boundaries. Well, I know that this is y equals 3 minus x. This is y equals 0. That's x equals 0. Okay. Number 4, find f sub x and f sub y and set them both equal to 0. Okay, so f of xy, the original, is x cubed minus 3x minus y cubed plus 12y. I want to find f sub x. That's going to be 3x squared minus 3. I want to find f sub y. That's negative 3y squared plus 12. I want to find out when they both equal 0. Well, 3x squared minus 3 is going to equal 0 when x is plus or minus 1. 3y squared plus 12 is going to equal 0 when it's 3 times 4, which means y is plus or minus 2. So what that gives us is actually 4 test points. The point 1, 2, the point 1, negative 2, the point negative 1, 2, and the point negative 1, negative 2. Except I need to make sure those are on my region. Well, my region only has positive x values and positive y values. So that's not in my region. And the point 1, 2 would actually be right on the line, y equals 3 minus x. That's a coincidence. So I am going to test that one. So 1, 2 is another candidate. What I just did is I tested inside and a little bit on the edge of the region to see if there's any relative extrema that might crop up. Now I'm going to test the edges specifically. I have 3 edges, 1, 2, and 3. I am going to test all 3 separately. I'm going to move this over a little bit because I want to keep space for my test area. All right, boundary number 1 is the boundary x equals 0. So I'm going to use the original function and do f of, let's see, if x equals 0, it would be f of, 0, y. Because if x equals 0, I'm replacing the x with a 0. And f of 0y means the x portion of this equation would disappear. And I would just have negative y cubed plus 12y. I just turned a multivariable function for the edge into a single variable function that I can now differentiate and set equal to 0. So f prime for this would be negative 3y squared plus 12. Set that equal to 0. Y equals plus or minus 2. So now my candidates here are 0 and plus or minus 2. Check to see if it's in my region. Well, my region only goes from 0 to 3. Sorry for the jumpiness there. So 0, negative 2 is not in my region, but 0, 2 is. So I'm going to test 0, 2. Now on to region number 2, or I should say edge number 2. Edge number 2 is the edge y equals 0. So that would be f of x 0, which means all my y stuff would disappear. X cubed minus 3x. I want to know when the derivative of that equals 0, which is when x equals plus or minus 1. Y is the one that's 0 this time. But my region only includes positive values of x and y up to 3, so that thing's out, and I need to test 1, 0. And last but not least, and definitely not least because this one takes the longest, I need to deal with my third edge. My third edge is y equals 3 minus x. So I need to find f of x 3 minus x, which is going to take a little bit more space than I have here. So I am going to use the next line and say this will become x cubed minus 3x minus y cubed plus 12y, but y is 3 minus x. It's an ugly one, but it's still a single variable function, so I'm going to take the derivative and set it equal to 0. So f prime would be 3x squared minus 3 minus 3 minus x squared times negative 1. because of the chain rule. And then this would be 36 minus 12x. So really just a minus 12 at the end. And I'm supposed to set that equal to 0. So that's going to be 3x squared minus 3 and minus 12 would be minus 15 plus 3 times 9 minus 6x plus x squared. So this is going to be 3x squared plus another 3x squared is 6x squared. And then negative 18x. And then 27 minus 15 is 12. Set that equal to 0. X squared minus 3x plus 2 equals 0. I divided everything by 6. Then I want to factor minus 2 minus 1. So x equals 2 and x equals 1. And if x equals 2 and y is 3 minus x, y would be 1. And if x equals 1, y would be 2. And the point 1, 2 and 2, 1 would both be on my region. But look at this. I've already got 1, 2 already, so I'm not going to write that again. So I'm just going to write 2, 1. Whew. All right. So I now have 1, 2, 3, 4, 5, 6, 7 candidates for my absolute max and absolute min. All right. I am going to now plug these back in to the function, but thank you, GeoGebra, it can do that for me. So I am going to bring up GeoGebra slowly. There we go. And type f of xy, and you can do this too, is x cubed, what was it? Minus 3x minus y cubed plus 12y. And I get this funky looking thing. Whoa. All right. I would have to zoom way out. I wish there was a better way to zoom in this. There we go. That's what this looks like. It's got that big, like, bumpy thing there. And so, like, that bumpy thing, depending on what my region is a relative max. But if I don't include this part, it's also an absolute max. So now we're going to kind of figure out, where are my points here? So let's see. I had f of, what are the points we needed? 0, 0. Oops. F of 0, 0. And that's 0. And then f of, let me put 0 there. F of 0, 3. 9. F of 3, 0 is 18. F of 1, 2 is 14. F of 0, 2 is 16. F of 1, 0 I can do in my head because that'd just be 1 minus 3 is negative 2. And f of 2, 1 is 13. Okay, so what's my absolute maximum value? 18, and it happens at the point 3, 0. Now let's see if I can plot that here. Sometimes it works, sometimes it doesn't. 3, 0, 18. Can we see it? I see a dot. Nope, that's on the axis. 3, 0, 18. Unfortunately, it doesn't plot it. That makes me sad. I thought it would. But 3, 0, 18 is on there somewhere. I wish I could label it. Yeah, it just won't let me. So 3, 0, 18 is a point somewhere on there. And then the lowest point is 1, 0, negative 2. So negative 2 is the absolute minimum value, and it occurs at the point 1, 0. I have rambled long enough. Instead of leaving you with a joke, I'm going to leave you with another ridiculous factoid about Mrs. Bibber. So when my son Max was born, I kind of got to pick the day he was going to be born because we had to do a C-section. And so I picked June 12th. And so what I did with that information As I said, if he's going to be born on June 12th, that's 6/12. I made him a shirt that said absolute max, and the maximum value was on a parabola that was upside down and had a maximum point of 6/12, and I made him a t-shirt with puffy paint because I am that person. All right. I hope everyone's having a glorious day. We'll talk again soon about this stuff.